Control of microorganisms is an essential factor in maintaining good health. This control can be achieved by sterilization and disinfection. In this program today, we will see various methods of sterilization and disinfection. We shall also examine their uses and modes of action. Before we go in details of each, let us understand what we mean by terms such as sterilization, disinfection, and antisepsis. Sterilization is the process of freeing an article from all living organisms, whereas disinfection is the process of freeing an article from harmful microorganisms and not necessarily the harmless ones. Antisepsis is use of chemical agents to disinfect living tissues such as skin or wound. This prevents the infection by inhibiting growth of harmful microorganisms. Now, let us see various methods of sterilization. There are two methods of sterilization, physical and chemical. Under physical method, in this program, we will deal with heat, radiation, and filtration. Heat is one of the most effective, reliable, and economical sterilizing agent. Because of these reasons, it is the most widely used method. The killing rate of heat is expressed as function of time and temperature. For example, typical bacilli can be destroyed in 30 minutes at 58 degrees centigrade, in 2 minutes at 65 degrees centigrade, and just in few seconds at 72 degrees centigrade. This shows that the higher the temperature, the lesser the time is required to destroy the microorganisms. Each microorganism has thermal time, that is, the time required to kill microorganisms at a given temperature. In this chart, we see various temperatures along with the time required to destroy different types of microorganisms. Heat is of two types, dry heat and moist heat. The principle of using dry heat involves killing of essential cell constituents. As you have seen in this chart, to kill spores, we require a temperature of 160 degrees centigrade for 1 to 2 hours. Sterilization by dry heat is done in a hot air oven by incineration or burning and by applying direct flame. In direct flame, we hold objects in the flame till it is red. This is used in the hospital for sterilizing needles, points of forceps, and inoculating wires, etc. Burning or incineration is used in the hospitals to destroy infected swabs, sputums, cups, books, beddings, and lab material, etc. It is the safe, cheap, and excellent method of sterilizing any unwanted objects. The hot air oven consists of a double-walled chamber which is heated electrically. It has a temperature control, pilot light, automatic timer, and a thermometer to record the temperature inside the chamber. Before loading the chamber, the items to be sterilized are packed properly. After packing the objects, they are kept inside the chamber, taking precautions that they do not touch the walls. The door is closed, the temperature is adjusted to 160 degrees centigrade, and the switch is put on. The current is switched off after 1 to 2 hours as required. When the chamber is cool, the door can be opened and sterilized objects are now ready for use. What are the items that can be sterilized in hot air oven? Hot air oven is used for sterilizing glass syringes, oils and powders, liquid paraffin, and blunt instruments. Certain articles as powder and oils can only be sterilized by dry heat. But in order to sterilize articles more rapidly and effectively, moist heat is a better method, as water is a good conductor of heat. Further, steam penetrates into the object and at a lower temperature and in less time. Another important aspect of heat is that it coagulates the albumin of bacteria and causes it to die. It also destroys the enzymes of bacteria, and bacteria cannot carry out their activity further. For moist heat to be effective, two important points have to be kept in mind. All parts of load should be in direct contact with water and steam. The temperature of the water should be above that of boiling point. To build up this temperature, we need a pressure vessel, and this is called an autoclave. Autoclaves are of different types: vertical, horizontal, and simple pressure cooker type. The autoclave consists of a metal tank heated by electricity or gas and having a lid. The lid bears a tap for discharge of air and steam, a pressure gauge, and a pressure stat which keeps the temperature and pressure at the desired level. While packing the material for sterilization in an autoclave, we should keep two things in mind. Firstly, it should be packed in such a way that it should allow steam to enter and air to escape from the packet. Secondly, the packing should protect the material from contamination by bacteria from the environments after the removal from the autoclave. Here you can see the material to be autoclave being packed. Glass syringes, dressings, gloves, and rubber catheters are properly packed and wrapped in permeable wrapping, cloth, or craft paper. A chemical indicator strip is also put on the packed material to check the satisfactory completion of the process. After packing, the load is kept in the autoclave drum. The position of the holes in the drum is changed to open position. Sufficient water is poured in the autoclave chamber. The drum containing the load is kept on the perforated tray just above the level of water. The lid is then screwed down to close the chamber. The discharge tap is open, the electricity is turned off, water starts boiling, air and steam is allowed to circulate for 5 minutes. The discharge tap is closed, the pressure is allowed to build up till the required level. The pressure is usually reached at 1.1 bar at a temperature of 121 degrees centigrade is employed for 15 minutes. The electricity is then turned off, autoclave is cooled till the gauge shows that the chamber is at atmosphere pressure. Tap is opened, air enters the chamber. Finally, the lid is opened, the drum is removed, and the holes in the drum are brought to close position. The chemical indicator strip on the load now shows a color change from white to black, indicating that the process of autoclaving is complete. In this way, we can sterilize in an autoclave materials such as dressing, linen, gloves, which are not destroyed by heat, and also certain lab reagents, powders, and other materials. Objects which cannot be sterilized by heat are sterilized by filtration, radiation, and exposure to gases. Ethylene oxide is a highly penetrative, non-corrosive, and microbicidal gas. It is used in industries for the sterilization of heat-sensitive medical devices. Prosthetic heart valves, disposable syringes, drip sets, catheters are some of the devices sterilized in this way. The other method of sterilization is by radiation. Ionizing rays are lethal to cells, including the spores. This is used for sterilizing heat-sensitive pharmaceuticals, such as vitamins, hormones, antibiotics, disposable items, and suture materials, etc. Another physical method of sterilization is filtration. Filter is a mechanical device for removing microorganisms from solutions. The fluid passes through the filter, the organisms are trapped in the pores of filtering material, and the decontaminated solution is collected in the flask. It is possible to render fluids and bacterial cultures free from bacteria by passing through special filters having a pore size of 0.45 millimeter. There are two types of filter, Sitz filter and membrane filter. Now let us see a Sitz filter. This is the metallic filter assembly. This is the perforator. We put the asbestos between the perforated disc and tighten it. Then the filter can be fitted over a flask which may be attached to a suction apparatus so that the pressure gradient is created which causes the fluid to filter. The other type is the membrane filter. This is a membrane filter assembly. This is the cellulose membrane which is to be fitted in the assembly. For small quantities, we fix it to a syringe and collect the filtered fluid in a small sterile flask while the bacteria get trapped in the cellulose membrane. The filter is used to remove the bacteria from IV fluids, antibiotic solutions, and blood products, etc. Up to now, we have seen various methods of sterilization. In sterilization, microorganisms are controlled through physical agents by destruction of life, including spores. On the other hand, chemical agents destroy only pathogenic organisms on or in an object. This process of destroying the organisms is called disinfection, and the object is said to be disinfected. If the object is lifeless, such as a tabletop, the chemical agent is known as disinfectant. However, if the object is living, such as a tissue of the human body, the chemical is called an antiseptic. Now, let us have a look at the various chemicals used for disinfection. In the class of phenol and cresol, we have Lysol and Dettol. In alcohols, ethyl alcohol or methylated spirit. In halogens, we have iodine and chlorine compounds. In aldehydes, we have formalin. In the class of dyes, we have gentian violet. In the class of acids, we have boric acid and carbolic acid. Under gases, we have ethylene oxide. In the class of metallic salts, we have mercury, silver, and copper. In oxidizing agents, we have hydrogen peroxide and potassium permanganate. For the surface active agents, we have soaps. The effectiveness of these chemical disinfectants depends on the following: the concentration of the disinfectant, the number and type and location of microorganisms, the temperature and pH of treatment, and the presence of extraneous materials such as organic or other interfering substances. You must have already used some chemical disinfectants in your daily practice. Let us recall a few of these. To disinfect ampoules, we use alcohol or methylated spirit or povidone iodine. To disinfect thermometers, we use 2% glutaraldehyde or 2.5% povidone iodine. To disinfect cheatal faucets, we use 2.5% povidone iodine or 5% chlorhexamide plus citramide, commonly known as Savlon. To disinfect sharp instruments, we use 2% glutaraldehyde or 5% carbolic acid. To disinfect cystoscope, we use 2% glutaraldehyde or 5% carbolic acid. And to disinfect surfaces, etc., we use Clorox 1:100 dilution or 5% carbolic acid or 2.5% povidone iodine. Some important points to note are: all articles to be disinfected should be free from organic matter and should be clean. The solution should be changed frequently, and thorough cleaning is a prerequisite for successful disinfection. Apart from chemical agents, some other means of disinfection are moist heat, which includes boiling and pasteurization, disinfection by ultraviolet radiation, gases, and filtration. Now, let us summarize what we have learned today. We have learned the definition of sterilization, disinfection, and antisepsis. Sterilization is the process of freeing an article from all living organisms, whereas disinfection is the process of freeing an article from harmful microorganisms and not necessarily the harmless ones. Antisepsis is use of chemical agents to disinfect living tissues such as skin or wound. We have also learned about the various methods of sterilization, uses and modes of action of hot air oven, autoclave, sitz filter, and membrane filter. In disinfection, we have learned in details about the various chemical agents commonly used for rendering the material free from microorganisms.